to do is we're going to look at the impact of taking my original balanced chemical equation for my system at equilibrium and what happens if I multiply it by factors to change the coefficients. So here we have a system where we have 2 sulfur dioxide react with oxygen to form 2 sulfur trioxide. And what we're going to do is we're going to look at the impact of both flipping the equation and also dividing all the coefficients by 2. Okay, now for my initial equilibrium, we know that my equilibrium expression is going to be equal to the concentration of the products. So in this case, SO3 raised to its coefficient, so squared, divided by the concentration of the reactant, so sulfur dioxide raised to its coefficient 2, times the concentration of oxygen. Okay, so what happens when I flip my equation? Well, to go from my initial equation to my new equation, I multiplied by a factor of -1. So if I were to write the equilibrium expression for my new equilibrium, or the flipped equation, I would know that my equilibrium constant is going to be equal to the concentration of the products. So in this case now, sulfur dioxide and oxygen are my products, raised to their coefficients, divided by the concentration of my reactants, raised to their coefficients. Okay, well, since I multiplied my equation by -1, what I'm going to do is I'm going to factor out a power of -1 from each of my expressions. So that would actually flip my equation and give everything a power of -1. Well, I can see now that this equilibrium expression is equal to, or is the same as, the equilibrium expression for my original equation. And so I can substitute that in. And what I see is that my equilibrium constant for my new equilibrium, the flipped equation, is equal to the original times -1. Okay, let's take a look at a second example. To go from my original equation to my new equation, I multiplied by a factor of 1/2. So again, I have my equilibrium expression for my original equation. And what I'm going to do is I'm going to look at the equilibrium expression for this new equation where I times it by 1/2. And again, I'm going to take the concentration of my products, in this case, sulfur trioxide raised to its coefficient, which now is 1, and divided by the concentration of my reactants. Now, just like I did before, because I multiplied it by 1/2, what I'm going to do is I'm just going to factor out a 1/2 exponent from each of them. And now again, I can see that this expression or value is the same as that. So therefore I can substitute in, and I see that my new equilibrium is equal to the original times 1/2. And so from both of these examples, what we can see is that if I take an original balanced equation and I multiply it by some coefficient or some value to change the coefficients in my balanced equation, then what happens is that the new equilibrium is going to be equal to the original raised to the power of my multiplier. So for example, if I took my equation and I were to multiply it by 3, so now I had 6 SO2 gas plus 3 O2 gas to form 6 SO3 gas, then the equilibrium constant for this reaction would be equal to my original equilibrium constant. And then because I multiplied my first equation by 6 to get to this, or by 3, sorry, to get to this, I would therefore raise this to the power of 3.